Hello, my name is Bradley Noyes, and today we're going to be talking about CNC mills, which are, they could probably justly be called the backbone of precision manufacturing. They're what almost everything is built on. So, starting off, what is a CNC mill? So, the first thing is CNC stands for computer numerically controlled, which is a fancy way of saying that it runs off of code. It's not manually controlled, but the operator inputs code to it, and the computer controls it much more precisely than a human ever could. So they're an extremely versatile machine. Basically, anything that needs manufactured, you can almost always do it in some way on a mill. If it was round, you would probably use a lathe, but in almost any other situation, unless it's extremely specialized, a mill is going to do the job. And because of that, they see widespread use. Anytime you go into a machine shop, anywhere they do manufacturing, mills are probably going to be the most common machine because they're so versatile and can do so much. So, excuse me, mills can be divided into, or they're usually classified by their number of axes, that is, the number of directions they can move or rotate. So the most common type is going to be a 3-axis, meaning it moves up and down to the right and left, and then backwards and forwards. But you also have 4 or 5-axis as well, which usually means that they have those 3 directions of rotate or of movement, and then 1 or 2 directions of rotation as well, which allows you to do more complex parts. So then the major components of a mill that we're going to break this down into is the work table, which is the central surface that everything is attached to, that the part is attached to, that the operator actually works with. And then the spindle, which is the part that holds the tool that's in the picture here. It's what actually spins the tool and does most of the work. And then you have the control panel, which is also very important part of it's what the operator needs to control the machine. It gives them options for manual control or to see what's going on with the code and to control where it's at in the code that's loaded into the machine. And then this is an optional part, but most machines, especially industrial ones, will have a safety enclosure as well. Cheaper hobbyist ones or ones for like a personal use generally won't, but most expensive ones do. So the first part is going to be the work table. It provides, the biggest thing is it provides a flat surface to work on. You can see in the picture here, the work table is that central part with the grooves in it. So it provides a flat surface to put the part on to attach it to, because precise machining, it requires you to have very precise placement. And so if you had a surface that wasn't flat, that wasn't smooth, you wouldn't be able to achieve what you're trying to do. So it's very important that you have a flat surface and a hard surface. And then they're usually going to have grooves or holes for attachments. You can see in the figure here, there are grooves in there. So the purpose of that is for you can put bolts or screws or other types of attachments in there to hold the part in place, because there's very large forces going on with these machines, and so you need very strong attachment points and anchors to keep everything in place. And then so you can see in the figure here, like we talked about before. So generally, they're gonna move the work table is gonna move laterally. So it's gonna move along the x-axis and the y-axis, so horizontally and like backwards and forwards. There are some cases on more complex 4 and 5-axis machines where it can rotate as well, but in the vast majority of machines, it's just going to be that lateral movement. And then the second part is going to be the spindle. Like we talked about before, that's the part that actually rotates the cutting tool. It's the part that does the cutting. And the spindle usually is going to have a pneumatic chuck, as opposed to, if you've ever used a drill or something like that, that'll have a chuck that screws down. These machines usually have a pneumatic chuck, which means that the tool is held in by air pressure, which there are benefits and drawbacks to that. It's more complex and more expensive, but it also it's more consistent and it's much quicker, because rather than screwing and unscrewing the tool in and out, you can just pop it in and pop it out by pressing a button, which is much faster. And it also enables mills to have tool changing systems that are automatic. So without any operator input, they can swap which tool is in the machine so that they can perform various different tasks. And then in most machines or most mills, that is 3-axis ones, the spindle moves vertically along the z-axis, So the work table moves horizontally, and the spindle moves up and down as needed, which provides all six directions of movement. There are some mills where the spindle is situated horizontally, and so it moves laterally, and the work table can move up and down. And the benefit of that would be that the bit has more contact with the part, so there's more surface area being cut away, so it's quicker, but it also it wears out the tool faster, and it's generally less useful for most applications. The third part is going to be the control panel. This is the part that the operator is going to be using the most while the machine is running. So it has a screen that it'll display what the mill is doing, what part of the code it's running, where in the coordinate system the tool is located right that second, and where it's moving to. It allows the operator to control the mill manually, which is important sometimes for like calibrating and things like that. And like precise machines like this, they require very precise movement, very precise calibration. So that can't all be done automatically. There has to be some operator input of telling the machine where the coordinates are going to be based off of, because they work in XYZ coordinates, and you have to be able to tell the machine, okay, this is 0x, this is 0y, this is 0z, and what direction is positive, so that it knows when it moves, it knows exactly where it's at. And then also very important part, the big red button there, which is going to be the the emergency stop, usually called the E-stop, which all machines have to have those. Just a big red button you press that immediately shuts down everything in case of an emergency. And the fourth part, the optional part, is going to be an enclosure. And you can see here in this figure, you can see the work table and the spindle and the control panel, but they're all attached to this big enclosure here. Not all machines have that. So that's helpful because it protects the operator, because these machines are moving very quickly, and so they often involve flying debris, which could be very harmful to people. It protects components on the inside from it protects the components on the inside from harm, from things coming outside and damaging them. It helps maintain the cleanliness of the workshop, because it keeps all the coolant, all the chips, all the flying parts stay inside the machine and don't go out into the shop, which could be dangerous. And it also just makes the shop quieter, which is it's good for the health of the workers and just the general work environment. So that's going to be everything. Thank you for listening, and I hope that you understand more than you did a few minutes ago. Thank you.